Hello, my name is Ricardo Gonzalez, and today I will show you the behavior of an object in rest falling down. In other words, an object in freefall. But before going in with all of the details, I would like to show you my tracker video first. Now, the system of my experiment is the jar of Nutella. And notice how the last point of mass is exactly at the bottom of the floor. Now, from this tracker video, we can extract the essence of free falling, which is that the object is speeding up every interval of time because the distance between the points of mass is getting larger. This is very important to notice. In this experiment, we are going to determine the behavior of the motion of a falling object that was at rest, as I said previously. And the results found in this experiment show that drag has to be taken into consideration in order to obtain more accurate results, because drag is always present in the falling of objects, at least here in planet Earth. The system is the jar of Nutella, the fundamental physics principles is Newton's second law, and the surroundings is air drag and gravity, which is equal to 9.8 meters per second square. Now here is all the data that is taken into consideration, and here are the procedures used to determine values such as the final velocity, force net, and the final velocity when force net takes into consideration gravity and force drag. Now I will show you my code. The arrow scale used was 0.35 and the value of B was 0.195 because it was the most accurate one. Now if we run it, we will see that the force of gravity was much more higher than the drag force, which in this case depicts that the drag force had minimum influence over the motion of the object. Now, collecting all the data collected from Tracker and Python, we can express them in a graph. The blue line represents the model of the gravity, the dark orange dots represent the observations recorded from Tracker, and the light orange line represents the model that takes into consideration drag and gravity. We can see that they have slightly different values, but the observation and the model of drag have the same final position, but they reach there in different times. Now, these slightly changes can be caused by the fact that there could have been human errors while selecting the point of mass, or maybe the camera was tilted a little bit, or perhaps the object didn't fall 100% vertically, which would all affect the values. What if the object was initially thrown downward? Well, from this equation we can see that if it has an initial velocity of 2 meters per second, then the final velocity would be 7.55 meters per second. So it would be higher than the one that was calculated earlier, which is 5.55 meters per second. What does it mean? Well, both models predict a final velocity because we know the Fnet in both cases. The difference would be in the final velocity's value. With drag, the terminal velocity is less than with only gravity because drag force has an upward direction. Thank you for your attention.